All right, so we're going to work on some more trig identity stuff today. I have down that we're starting on 4A. Our learning target is just to simplify trig expressions using trig traits. Does that look like 4A? That question is not very big. Let me see if I can just make this little question bigger. That's a little better. Okay. There's several ways we could attack this one. And some of them are ways that you wouldn't necessarily think to do. What's happening here? There we go. Come on. All right, sorry. When you have a fraction, like, let's say it said 1 plus 3 over 5. That's just 4/5, right? But it is the same if you did that. Does that seem true to everybody? So we could actually separate this. The reason I look at it that way is because tangent over tangent would be 1, right? So we could separate it, tan theta plus cotangent theta, and put each of them over tangent of theta, because they're currently both over. So this would become a 1. Some of you might recognize what this is. For some of the rest of you, I'm thinking not so much. Maybe you would go with sines and cosines. What do you think? Some of you would. So the top would be cosine over sine. Okay, and the bottom is sine over cosine. So when you divide, what do you do with a fraction? Yeah, which one flips over? We have a cosine over sine that's being divided by sine over cosine or multiplied by the reciprocal. This one would flip over. Do you want me to write it out? Maybe I'll write it out. If you don't write this step down, that's fine, but it's currently being divided by sine over cosine, which means when you flip it over, it becomes cosine over sine. Okay. So what do we get? What's a cosine over sine times a cosine over sine? A cosine squared over a sine squared. Does anybody know what that is? That is a cotangent squared. Now I'm down to something that might be an identity. Is that one of our trig identities or not? Might be cosecant squared, or it might not have the right sign. I can't remember. It is cosecant squared? Okay. So this would be down to a single function, but let me go back up here. You don't need to copy down both ways, certainly. But let me think how else we could have done that, because I just want to make it clear that there's more than one way to do these. So on the top, if I had rewritten that as sine over cosine plus, maybe I should do this in a different color. Sine over cosine plus cosine over sine, all over sine over cosine. How many of you think if you had seen that problem, you probably would have done that? Yeah? Some of you? Okay. Because that's the go-to for a lot of people, is change everything to sines and cosines. if we said this top is being divided by the bottom, that would mean the top was being multiplied by the reciprocal of the bottom, which would make it cosine over sine. Okay, just trying this one a different way. What would you do there? When you have a quantity added and being multiplied by a quantity, what do we need to do? If it said x plus 1 times 3, what would you do? Distribute, right? So if I distribute this here and here, guys, just stick with me to finish this question and then we'll move on, okay? Sine over cosine times cosine over sine would have become what? Sine over cosine times cosine over sine. Wouldn't everything have canceled? We'd just get 1. And then when you distribute it here, you'd have a cosine squared. Down here on the bottom, you'd have a sine squared. And then it would have gone on from there, okay? Just trying to show you that you should be able to get the right answer any way that you attack it. Okay. We're skipping to C here. Is there a trade for the top? Let's see. Is there one that says tangent squared plus 1 equals secant squared? Is that the one off the sheet, guys? Or did I write it wrong? Okay. So if we subtract this 1 over here, a secant squared minus 1 should trade for a tangent squared. And the bottom had a secant squared. What might be your next try? Okay. Do you want to change them to sines and cosines, or you just want to? Okay, that's what I was. So the tangent squared, let's see, would be a sine squared over a cosine squared. And it's currently being divided by, what is secant squared, guys? 1 over cosine, and it's squared. So then when you flip it over, to change the division to multiplication by a reciprocal, what did we end up with? Just a sine squared. Everybody okay? Anybody lost? Whenever you see that plus or minus in there with a squared something, look for one of those Pythagorean identities, okay? Now, just what if someone had tried this? They separated it. So they wrote secant squared over secant squared minus 1 over secant squared. What would a secant squared over secant squared have become? That would have been a 1. And what's the reciprocal of secant? Cosine. So a 1 over secant is a cosine. And then could you have used a Pythagorean identity to trade 1 minus cosine squared for a sine squared? Okay. So separating it would have gotten you there as well. All right, can you guys try D? I think just change it to sines and cosines. It's just multiplying. Give you a little confidence back after doing 2 funky ones. What'd you get? Did everybody get one? Tangent is sine over cosine. Cosecant is 1 over sine. And then it said times cosine, so there was a sine here, a cosine here. Everybody okay? That'd make a good quiz question, right? Nice easy one. All right. we're going to skip verifying identities until Monday. So at the very bottom, I think, of this worksheet, is there just a couple factoring questions? Sometimes we need to be able to factor trig things. And so we're just going to talk about factoring algebraically first. What do we want to factor when we see this guy? Do we need two sets of parentheses? It's not a trinomial, right? It's only a binomial. There's only two terms. So what can we do to the two terms? It's not the difference of perfect squares, but we can take out what? An a squared. What will be left? Be careful. 1 minus b. Don't lose that 1, okay? You're dividing out each term by an a squared, and a squared over a squared is 1. It's got to FOIL back to what we had. Not FOIL, distribute back to what we had, okay? All right, what about b? That one is a trinomial. There's 3 terms. X squared is an x and an x. To get a 1 at the back, we need a 1 and a 1. What signs would give us a -2 in the middle? -1 and -1. We have a -1x and another -1x. So we'd get that -2x in the middle. Now, that could also have been written like this. Everybody okay with that? X minus 1 quantity squared. So just trying to make this very, very clear, if it said x minus 3 quantity squared, it was a trinomial, right? It was an x squared and a plus 9, but there was also a middle term. When you do x minus 3 times x minus 3, you would get minus 6x, I think. Okay, just trying to remind you that this does not become an x squared plus 1. It has a middle term. Same way this one does not become an x squared plus 9. There's a middle term. All right. So example 4, we're going to skip because it's a verifying question, and we're going to do those on Monday. Can you go to example 5? It says there are 2 different ways you can leave this answer. It asks that in the notes we leave it only in terms of sine squared, and it says later on a homework you'll be asked to leave it in terms of cosine squared. But let's just see what happens when we FOIL this together. So sine times sine becomes what, guys? Sine squared. And then if we do sine times cosine, that's positive. So we have a positive sine times cosine. And everybody gets that that's the same as a cosine times sine, right? It's like an AB, BA, same thing, right? And then if we do distribute this guy, we have a negative cosine of theta times a sine of theta, which is really the same as this sine, cosine, cosine, sine. Those are the same. Yes, they will cancel each other out. Yep. So this is a negative cosine times a positive cosine. What's a -1 cosine times a +1 cosine going to become? A negative cosine squared. Good job. All right, so I didn't write these in the same order. I wrote one as a sine cosine and one as a cosine sine, but you understand that they're the same, okay? And one was positive and one was negative. So like Jada said, that's just going to become 0, or those are going to cancel each other out because one is added and one is subtracted. So what's left? Sine squared theta minus cosine squared theta. Now, is that 1? Can you look at your Pythagorean identities? There's one on our sheet that says cosine squared plus sine squared equals 1. So does this equal -1? If we change this so that it was negative, wouldn't it change both of those? Okay, that's true, but this is not. So they asked that we leave it in terms of sine squared. So what do I need to get rid of if I want it in terms of sine squared when I'm done? I need to get rid of a cosine squared. Is there something you can trade a cosine squared for? And I don't mean 1 over secant. That would be a mess. Look at this guy right here. How could I rearrange this so that it said cosine squared? Or better yet, negative cosine squared. But if I subtract that over there, that would be the cosine squared, right? But I got to be careful. There's a negative here. So I'm going to go sine squared theta minus, and I'm going to replace cosine squared with a what? Yes, I'm going to subtract the sine squared over to the other side. So I'm going to replace cosine squared with a 1 minus sine squared. My guess is that might even be at the top of your page. Let me look. On the top of 2a and 2b, can you look on the top of 2a or 2b? I think it's the same chart. But that little chart clearly shows that cosine squared can be replaced with a 1 minus sine squared. Do you see that? It's like on the right-hand side in the middle. Okay. But you got to watch that minus out front. So then what do we need to do? Yeah, we're going to distribute that negative. We distributed the negative. And then what can we finally do? I don't know. This is one where you wouldn't know you were finished, except that they told us to have only sine squareds when we're done. Sine squared plus a sine squared is 2 sine squared and a minus 1. There is nothing nice about that. Now, if you have your peach sheet out, this is actually very similar to something down in the double angles. Do you see down in the double angles? Way down there, we're going to do some of those next week. There's one says 1 minus 2 sine squared equals cosine of 2 theta. Do you see that one down there? So eventually we might want to trade that for a negative cosine of 2 theta. But that's not what it said to do today. So this is just a weird one. I just want to lead you through that. I would not ask you that on a quiz unless I told you what I wanted it to equal, which is going to be called a verify question. If I said, work with this left side until it looks like the right side, okay, then you'd know where to stop is the whole point. Okay. All right, let's try B. What are we going to do here? I think we better write it out so we can FOIL it. Tangent plus 1 times tangent plus 1. So someone nice and loud, tell me what you get when you do some FOIL. Tangent times tangent. Tangent squared. 1 times tangent is just a tangent. Another 1 times tangent is another tangent. And that 1 times 1 is a plus 1. What would that become? Nothing nice, I don't think. Tangent squared plus, what do these two guys become? 2 tangent theta plus 1. I don't really know where they're going with this. I think we could probably be done. Is a tangent squared plus 1 anything? Oh, it is a secant squared, right? But I don't think that's going anywhere. Yeah, I just leave it. I don't even know where they wanted us to end up with that. All right, what about this guy? I think this is just practice that it factors. Sine squared is like a u squared minus 2u plus 1. How would that factor, guys? Sign in one and sign in the other? And how do you get a 1 at the back? And how do you get a minus 2 in the middle? If you needed to factor it in terms of u first, it would have factored u minus 1 and u minus 1, and then you'll say, well, u was really a sign. So sine minus 1 and sine minus 1, which is sine theta minus 1 quantity squared. And I'm not going to ask you that on a quiz. I think eventually what you're going to have to do is some of this where it's set equal to 0 and you solve or something, okay? Let's see. Let's go to the top of 5A. They gave us numbers the first time to review how you have to add fractions. How do you have to add fractions? That's really tiny. I'll write it bigger. 2/3 plus 1/4. What do you have to do to be able to add fractions? If you can't do it on your calculator. Because it's going to have words in it in a minute. Or functions. 5th grade math, guys. What did you have to do to add fractions? Get a common denominator, okay? So what is the common denominator for 3 and 4? 12. So this needs to multiply by a 4, which means we multiply top and bottom by a 4 so that it's equivalent to what it was. And it becomes 8/12. What do we got to multiply by here? 3/3, and it becomes 3/12. And then when we add, what do we do? Add the top and do what to the bottom? Keep the bottom. So we get 11/12. All right, so we got to do the same thing on B. What is the common denominator going to have? A sine and a cosine. So this 1 over cosine would need to multiply by a sine over sine. And then this 1 over cosine, I think I'm going to write it. Oh my goodness, it's a 1 over sine. And what do we need to multiply that by? Cosine over cosine. I guess I'll leave it. Now, everybody's okay that the denominator cosine times sine is the same no matter what order we multiply it in, right? Okay, so what do we end up with on top? I don't know why that looks like an exponent or something. I made that really weird. On the top, we have 1 times sine, which is sine, plus 1 times cosine, which is cosine. Now, does a sine plus cosine equal 1? A sine squared plus a cosine squared equals 1. But remember, we can't just square root. My favorite example of that here. I thought that was an eraser. Didn't work, so it's still not an eraser. Sorry, guys. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, which is 5 squared, right? Can you square root that? Is 3 plus 4 equal 5? No. You can't. So that's when you try to tell me that a sine squared plus a cosine squared equals 1. Therefore, a sine plus cosine equals 1. That's kind of what you're trying to do. You're trying to square root things that you can't. Okay, does that help you understand why that doesn't work? All right, so we have this disgusting answer. I think that's where they wanted us to stop, honestly. There's nothing more you can do with that. I would not ask you that unless it was an identity, a proof, which means I tell you what I'm trying to get it to look like. Okay, we'll do those Monday. This one might go somewhere, I don't know. What would the common denominator be here? We did these and it wasn't very fun. Do you remember when we did like 1 over x minus 2 plus 3 over x plus 2 and you had to get a common denominator? Do you remember those? You had to multiply by an x plus 2 over x plus 2 and an x minus 2 over x minus 2. We got to do the same thing here. So it's 1 over 1 minus cosine, and we're going to multiply what onto this one? Yep, 1 plus cosine over a 1 plus cosine. And then we have a plus, and right now this guy has a 1 plus cosine already. Oops, 1 plus, sorry, I lost that. And what does it need to multiply by? A 1 minus cosine. We're not going to do D, by the way, so if you scribble over, and I think it's D. Maybe we are doing D. Nope, kidding, we're doing D. But we're not doing F. So if you need to move one of them down or something, I don't know. I'm trying to not have you run out of space. I'm sorry. I'm not being helpful. All right. How we doing? What does the top become up here? 1 plus cosine. Plus, over here, when we multiply, we just get 1 minus cosine. Okay? What happens in the denominator? When you multiply fractions, what do? Or sorry, when you add fractions, you add the top in. Keep the denominator. So down here we have a 1 minus cosine times a 1 plus cosine. Whatever order you want. Okay. What does the top become? This is one I could ask you. So hang with me here. Yep. A plus and a minus, that would be 0. So we end up with a 1 plus 1 is 2. Now, can we FOIL the bottom together? Anybody thinking ahead a little bit? What is that bottom going to look like when we FOIL it together? Are we going to have a middle term? 1 times 1 is 1. But here we get a plus 1 cosine. And if you don't write this, that's okay. If you can skip that step in your head. This one is a minus 1 cosine. And then what's a minus cosine times a plus cosine? Minus cosine squared. So what happens in the middle right there? Yeah. So we just end up with 2 over 1 minus cosine squared. Is that something? 1 minus cosine squared is... Yes, because it started out cosine squared plus sine squared equals 1. So if we subtracted this guy over here, 1 minus cosine squared would equal a sine squared. So we end up with a 2 over sine squared. Anybody know what they might trade that for? Yeah, because it's a 2 and there's a sign in the denominator, right guys? What does a sign in the denominator really mean? 1 over sine, so that is a cosecant, and it's squared. So this they might trade for a 2 cosecant squared. Again, I think if I was going to ask that question, I would ask it as a proof where I told you I wanted you to make it look like 2 cosecant theta, and you had to figure out the steps in between, and we'll do those Monday. Okay. I don't like when I don't know where I'm supposed to get to. All right. Got one more, two more. Okay, we can do this. What would a common denominator be here? This is currently over 1, so we need to multiply by tangent over tangent on this guy. What would the top become? Tangent squared over a tangent minus a secant squared over a tangent. Now, the first one reduces, but we don't want to reduce. We wanted to get a common denominator. When you have two fractions with a common denominator, you do whatever it asks and keep the denominator, right? What is a tan squared minus a secant squared? Is that something we should know? Well, there's an identity that said on my sheet, tangent squared plus 1 equals secant squared. So if I subtracted the tangent squared over here, what would I be left with? So I'm thinking, ooh, that's not what it says though. It doesn't say. It says tangent squared minus secant squared. Yeah, if we made this negative and negative and negative, the opposite of that. Yes. Let me explain it a little better. Let's back up. Oops, forward. Okay. This is what it originally said, right? I want it to say tangent squared minus secant squared. So I'm going to subtract the secant squared this way. So now it says tangent squared minus secant squared. What do I want to do with that one? Subtract it back to that side. Okay, so the top becomes negative 1 over a tangent. What's 1 over tangent? What's the reciprocal of tangent, guys? So we have a negative cotangent. All right, I think we're finally on the last one. Because I think we're going to do E, and if you look, isn't F exactly the same as one we did at the top, like maybe A or B or something? It was B, so we're going to skip that one. I don't think we need to do it twice. Okay, what about E? What do you want to do here? Blah, 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 blah. Want to get a common denominator? You want to change it to sines and cosines first? That's a good question. I don't think so. Let's just deal with this little piece for a second. And leave the plus 1, okay? They are reciprocals of each other. So it's kind of like a 5 divided by a 1/5, which doesn't become 1, unfortunately. Let's go ahead. Let's make it sine over cosine is being divided by what? Cosine over sine. And what do we do? And there's a plus 1 back here. Yeah, we got to flip it over. Whoops. So we end up with a sine squared over a cosine squared plus a 1. What's a sine over cosine? So that would be a tangent squared theta plus 1. Is that a trade for something? Tangent squared plus 1 is a secant squared of theta. Okay. In order to make this a little more like you know where you're going, I found a puzzle worksheet. Okay? Can you look at 3B in there? There was a couple nasty ones on it, so I did them for you. If you go to side 3B, okay, there's a puzzle. We can, so you need to do the puzzle. There's 2 done for you, and then there's some Delta math for you to work on. Okay, you have the rest of the hour and whatever, a weekend to get this work done. I'm going to stop the video, but if you want me to do a couple off the puzzle, we can. So I'm going to stop recording.